Welcome back to Nash Science Explained. Today we are diving into one of the most fascinating questions in physics, the speed of light. Why is it so important? And can anything go faster? Hey there, future scientists! Do you ever wonder how fast you can go? Maybe you like to zoom around your school at the speed of sound, breaking the sound barrier with a supersonic boom. Or perhaps you dream of blasting off into space faster than a speeding bullet. Well, if you do, you're in for a surprise because there's a universal speed limit, and it's the speed of light. In this episode, we're going to explore what the speed of light actually is, why it's the cosmic speed limit, and whether anything can break this ultimate speed record. So buckle up and get ready to learn all about the amazing science behind the fastest thing in the universe. What is the speed of light? First things first, let's define what we mean by the speed of light. Light travels at about 299,792 kilometers per second in a vacuum. That's fast enough to go round Earth 7.5 times in just 1 second. The speed of light is constant and is usually represented by the letter C in physics. It's a fundamental constant of nature, which means that its value doesn't change over time or in different places. This constancy of light's speed is a cornerstone of Einstein's theory of special relativity. Why is it a universal speed limit? Now you might be wondering, why is the speed of light considered a universal speed limit? Can't we just keep accelerating past it? Well, here's where things get really interesting. According to Einstein's theory of relativity, nothing with mass can reach or exceed the speed of light. Why? Let's do a little thought experiment. Imagine you're standing on a platform watching a train approach you at a constant speed. You see the train as clocked and notice that 1 second on your clock corresponds to 2 seconds on the train S clock. Time is passing more slowly on the train. As the train approaches the speed of light, this difference in time becomes more and more significant. As the train reaches 99% of the speed of light, a second on your clock would be equal to 10 seconds on the train's clock. If the train were to reach the speed of light, time would effectively stop for the observers on the train. All this is due to the equivalence of mass and energy described by the famous equation EMC, where E is energy, m is mass, and c is the speed of light squared. The energy required to accelerate an object with mass to the speed of light would be infinite. Therefore, it's impossible. What about particles faster than light? Now you might be thinking, what about those science fiction movies where spaceships travel faster than light? In theory, scientists have imagined particles called tachyons that might travel faster than light. However, no evidence of these particles exists, and their concept remains purely hypothetical. There are also theoretical concepts like wormholes that allow for travel between distant points in space-time, but these remain unproven. Faster-than-light concepts in science fiction. While faster-than-light travel is a staple of science fiction, it's important to remember that it's not currently possible. According to our understanding of physics, in movies like Star Trek and Star Wars, spaceships use technologies like warp drive, wormholes, and hyperspace to travel faster than light. These concepts are fun and exciting to imagine, but they are not based on any proven scientific principles. As for real-world applications, scientists are constantly pushing the boundaries of what's possible and making incredible discoveries about the universe. Who knows what the future may hold? Perhaps one day we will find a way to harness the power of the cosmos and travel at or faster than the speed of light. Conclusion, so there you have it. The speed of light is truly amazing. Not only is it the fastest thing in the universe, but it's also a fundamental constant of nature that helps govern the behavior of our universe. While we may never be able to travel faster than light ourselves, we can always appreciate the beauty and wonder of the cosmos and the incredible science that makes it all possible. So keep looking up at the stars and keep asking questions. You never know what you might discover. Thanks for joining me on this episode of Nash Science Explained. If you like this video, don't forget to hit the thumbs up button and subscribe for more fun science videos. And as always, keep asking questions. The more we know, the more we grow. See you next time.